Welcome. In this lesson, I want to take you through mole concept questions for the past Kcse questions. We want to start with this question number 3 here. A solution was made by dissolving 8.2 grams of calcium nitrate to give 2 liters of solution. Determine the concentration of nitrate ions in moles per liter. So first, let us calculate the Rfm of calcium nitrate. Rfm of calcium nitrate. So calcium we have been given, it is 40. Nitrogen times that is 14 times 2, 28. Oxygen, this is 16 times 3 times 2, which is 96. It will give us a total of 164 grams. That's 1 mole of calcium nitrate salt contains 164 grams in 1 mole. So 8.2 grams of calcium nitrate was dissolved. So let us get the number of moles that are present in 8.2 grams. We know how to get moles. Moles equal to mass divided by Rfm. In this case, it is 8.2 divided by 164. This gives us 0.05 moles. Now we have the number of moles of the salt that was prepared. But remember, 8.2 grams prepared a solution 2 liters in 2,000 centimeters cube. That is 2 liters. So this number of moles are in 2 liters. But we want concentration of the nitrate ions per mole per liter, right? It is per 2 liters. This is 2 liters. So we go on and say that 0.05. This is the number of moles present in 2 liters. 1 liter will contain how many? So it is 1 times 0.05 divided by 2, and this one will give us 0.025 moles. Calcium nitrate, because we have been asked to give the concentration of nitrate ions, it will give us calcium 2 positive plus nitrate. Yes, but the nitrate here, there are twice to balance it, there are twice 2 of them. So we have 2 moles of nitrate. So you can see now the ratio of the calcium to the nitrate is 1 to 2, 1 to 2. If the number of moles of the calcium is this one, what will be the number of the nitrate? So we say 1 equal to 0.025. 2 will give us what? 2 times 0.2025, and the answer is 0.05 moles per liter. So this is the number of moles of the nitrate ions in 1 liter. That is the modality. 100 centimeters cube of 0.05 molar sulfuric acid were placed in a flask, and a small quantity of anhydrous sodium carbonate added. The mixture was boiled to expel all the carbon dioxide. 25 centimeters cube of the resulting solution required 18 centimeters cube of 0.1 molar sodium hydroxide solution to neutralize it. Calculate the mass of sodium carbonate added. 3 marks. So this question needs us first to write the equation of what happened here. So we have two equations that is happening here. The sodium carbonate first will react with the sulfuric acid 0.05 molar, and then the excess acid is going to react with sodium hydroxide. So let us go to the last equation where sodium hydroxide is reacting with the excess sulfuric acid. To give us sodium sulfate plus water. Sodium sulfate plus water. So then let us balance the equation. That's what we have. We know that this one is 18 centimeters cube and the molarity is 0.1. 25 centimeters cube of this, so this one is 25 centimeters cube sulfuric acid that remained, which is reacting with sodium hydroxide. So first let us get the number of moles of sodium hydroxide, because here we have the molarity and we have the volume. So we can say that 0.1 is the number of moles in 1,000 centimeters cube of sodium hydroxide. Then 18 centimeters cube will contain how many? It is 18 times 0.1 divided by this, and it's going to give us 0.0018 moles. Yes. Next one, now we can get the number of moles of sulfuric acid that reacted with this. The ratio here is 2 to 1. So moles of sulfuric acid that reacted with sodium hydroxide is 0.0018 times a half, because the ratio is 1. The ratio is 2 to 1. So this one will give us 0.0009. This is the number of moles of sulfuric acid, the excess acid. But now this is the number of moles which is in 25, right? Now we remember 100 centimeters cube of 0.05 molar sulfuric acid was used. Therefore, for us to compare the excess acid with the original acid, we must get the number of moles in 100 centimeters cube, the excess acid. This one is the number of moles in 25 of the excess acid. So we say 0.0009 is the number of moles of which are in 25 centimeters cube sulfuric acid. 100 centimeters cube of this acid which was in excess will contain how many moles, so that now we can compare with this one. You cannot compare 25 with 100. Now this one is going to give us that is 100 times 0.0009 divided by 25, sorry, divided by 25, and it is going to give us 0.0036 moles. Yes. Now 0.036 moles, this is the number of moles that remained after reacting with the carbonate. So this is the number of moles of the sulfuric acid that remained after reacting with the carbonate. Now we know the number of we can now get the number of moles of the original and then subtract and see the number of moles of the sulfuric acid that reacted with the carbonate. So moles of the original is 0.05 is the number of moles in the original acid, which are in 1,000 centimeters cube. What is the number of moles in 100 centimeters cube of the original sulfuric acid? This one will give us 0.005 moles. But this one has remained after reacting with the carbonate. So we can get the number of moles of the sulfuric acid that reacted with the carbonate. So that is 0.005 minus what remained, 0.0036. Right? So this one is going to give us 0.0014 moles. And this is the number of moles of sulfuric acid that reacted with the carbonate. Now we can have the reaction with the sodium carbonate with sulfuric acid to get sodium sulfate plus water plus CO2 plus carbon dioxide. Yeah, sodium sulfate, water, and carbon dioxide is formed. The ratio of everything is 1:1. But we have the number of moles of sulfuric acid that reacted with the carbonate. Now we can get the number of moles of the carbonate. Therefore, this one is 0.0014. The ratio is 1:1, so moles of sodium carbonate equal to 0.0014 because the ratio is 1:1. The ratio is 1:1. Now, how do you get mass of a substance? Mass is given by moles times Rfm. Now we have the mass of the carbonate, the moles of the carbonate. We can get the Rfm from, we have been given the relative atomic mass of each. Therefore, sodium is 23. So out of sodium, 23 times 246 plus 12, 60 plus 48, 106. Therefore, 0.0014 times 106 will give us 0.1484 grams of sodium carbonate that was used. Next question. When excess lead nitrate solution was added to a solution containing sodium chloride, the precipitate formed was found to weigh 5.56 grams. Determine the amount of sodium chloride in the solution. Determine the amount of sodium chloride in the solution. So first, you must know how to write the chemical equations of the compounds or of the substances involved in an equation. So here we are reacting lead nitrate. Lead nitrate is Pb nitrate is reacting with sodium chloride. This one will give us lead chloride, which is a precipitate, plus sodium plus sodium nitrate. We will put it 2 here because of this, and then we will balance here with the 2 here. So all of these are aqueous and this one is a solid. The rest are aqueous. Now, we are told to determine the amount of sodium chloride. So first let us get the Rfm of sodium chloride. Lead. Sodium chloride is in my mouth. Why? So determine the amount of sodium chloride. Yeah, sodium chloride. We want the sodium chloride. But now we will start with lead chloride because the information we have is of lead chloride because the precipitate lead chloride was formed. So it is from lead chloride we start so that we can go back to calculating the mass of sodium chloride. So forgive me for the slipping of the tongue. Thank you. Now let us get the Rfm of lead chloride first. So Rfm of lead chloride equal to, we have been given 207 for lead, Chloride is 35 times 2, which is 71, and it's going to give us 278. Now, since we have the mass of the lead chloride that was formed, the precipitate, we can get the number of moles of the chloride that was formed, the red chloride. Then moles equal to mass over Rfm. Our mass is 5.5 divided by 278, and this one will give us 0.02 moles. 0.02 moles. Now the ratio, you can see the ratio of the sodium chloride and lead chloride is 2 to 1. So the mole ratio of sodium ions or sodium chloride to lead chloride is 2 to 1. But we have the number of moles of lead chloride, which is 1, 0.02. So what will be the number of moles of sodium chloride? It will repeat twice. So 2 times 0.02, which is equal to 0.04, is the number of moles of sodium chloride. Next one now is to calculate the mass of sodium chloride. Mass of sodium chloride. How do you get mass? Mass equal to moles times Rfm. So the Rfm of sodium chloride is 35.5 plus 23, which is 58. So this one is 0.04 times 58.5. This is the Rfm of sodium chloride, and this one will give us 2.34 grams. That is the mass of sodium chloride that was used. Next one is when excess diluted hydrochloric acid was added to sodium sulfite, 960 centimeters cube of sulfur 4 oxide gas was produced. Calculate the mass of sodium sulfite that was used. The molar mass of sodium sulfite is this. The molar gas volume is 2, is this one, and the max is 3. So first, it is important to always to write equations everywhere. Some chemicals are reacting. So here HCl is reacting with sodium sulfite. So write the equation first. HCl is reacting with sodium sulfite, which will give us sodium chloride plus sulfur 4 plus water. So you need to balance the equation. We have sodium twice of 2 of them, and you have to put 2 here to balance the chloride ions. Now that is the equation. You can write the status. It is not necessary for now. So what is important, what we want here is the mole ratio. The mole ratio, you must balance the equation well as required. You must balance. So let us see. We know very well that 1 mole of any gas at STP will contain this. STP, RTP, I think you should know those, room temperature, and the other one is STP. So let us get the number of moles of sulfur 4. So moles of sulfur 4 is given by, we know very well that 24,000 centimeters cube is the volume which is in 1 mole of sulfur 4 gas. 1 mole. 1 mole of any gas contains this volume. So we will ask 96 centimeters cube. 960 centimeters cube would contain what number of moles? So we will get that this times c divided by this, so it will be 24,000 divided by 9600, which will give 9610, that's 960, will give us 0.04. But we want to calculate the mass of sodium sulfite. What is the relationship in this equation? Now what we have is the mass of sulfur 4. The number of moles of sulfur 4. But now see, from the equation we can see the relationship using the mole ratio. So this one, the ratio is 1 and 1 here, meaning that the number of moles of the sulfur 4 oxide gas will be equal to the number of moles of the sulfate, the sodium sulfite. Since mole ratio equal to 1 to 1, moles of sodium sulfite equal to 0.04. Now, how do you get mass of a substance? So mass of sodium sulfite equal to its moles times its Rfm. So moles, the moles is 0.04 times the Rfm sodium sulfate. We have been given the molar mass. Molar mass is the same as Rfm, relative formula mass. So it is 126. And this one gives us 5.04 grams. And that is the mass of sodium sulfite that was used, or that reacted with sodium chloride.